I request some of you to come. Shweta, Sunil, Ayan, Halim. Please, some of you come here. Let's light lamp. Come, there's one more. ठीक है, ओके, हलीम करो.
साक्षात् परं ब्रह्म तस्मै श्री गुरुवे नमः. तस्मै श्री गुरुवे नमः. या कुन्देन्दुतुषार हारधवला या शुभ्रवस्त्रावृता या वीणावरदण्ड मण्डितकरा या श्वेतपद्मासना या ब्रह्माच्युतशङ्कर प्रभृतिभिर्देवैः सदा वन्दिता सा मां पातु सरस्वती भगवती निःशेषजाड्यापः निःशेषजाड्यापः शुक्लां ब्रह्मविचार सारपरमाम् आद्यां जगद्व्यापिनी वीणापुस्तकधारिणी अभयदां जाड्यान्धकारापः हस्ते स्फाटिकमालिकां विदधति पद्मासने संस्थितां वन्दे तां परमेश्वरी भगवती बुद्धिप्रदां शारदां बुद्धिप्रदां शारदां बुद्धिप्रदां शारदां.
So dear friends, welcome you all to this Gyan course on variational multiscale finite element methods in computational fluid dynamics, VEMS FEM in CFD. So, this is being organized under the auspices of MHRD, Government of India. So, this program is going to be conducted during May 4th to 14th. So, as you all see the schedule for this on all these 11 days. So, we have the schedule as announced here. We have 4 90-minute sessions per day, 2 in the morning, 2 90-minute sessions in the morning and 2 90-minute sessions in the afternoon. So, as you may note, the 90-minute session, the first in the morning session start at 9:30. The first session is from 9:30 to 11 with a tea break of 15 minutes at 11 to 11:15. Then at 11:15 to 12:45 we will have the second session. It will be followed by the lunch break 12:45 to 2 o'clock. Then 2 to 1:30 again we will have the next technical session, which will be followed by the tea break from 3:30 to 3:45, and the last technical session is from 3:45 to 5:15. So, this is tentative technical schedule. So, we will have time to talk even outside. We can talk even after 5:15 if you have anything to do. So, let me very briefly mention to you about the importance of this course, Variational Multiscale Finite Element Methods in Computational Fluid Dynamics. Finite elements, to begin with, is a powerful numerical tool which has emerged with the emerging computational technology. As the hardware progressed in 60s, there is a quantum leaps in terms of the hardware development. Then to take advantage of that from the numerical world, to solve the problems which are mathematically modeled, we require powerful algorithms, powerful methodologies. And one such powerful numerical methodology is finite element method. It is especially used for solving differential equations. Of course, one could use it also even for solving other empirical problems where the functional evaluation can take place, especially in the context when your domains are no more regular. You have an arbitrary domain and you may be ending up with, you may have to deal with the problems which are highly nonlinear, coupled, and the boundary conditions are not so easy to deal with. So, I have a complex domain with complex shapes. So, it could be nonlinear, geometric nonlinearity. The equations are nonlinear, coupled. So, we have a twofold nonlinearity, one in terms of geometry, one in terms of the governing model. So, finite element method has always been found as one of the very friendly methods for handling these kind of situations. So, where does a variational multiscale come into the picture? The multiscale. So, when you actually look at the phenomena that takes place in the world, so it is not, there are several time scales which are involved, there are several features which take place, fast and slow features, there are several things which happen both in space and time. You need to account for all these things with great care and accuracy. So, you need to tailor your methods which will take care of all the scales carefully. So, that is where the multiscale version of finite element method come into the picture. For instance, you may think of a simple thing like blood flow in the human body in a pathological condition when a person is diseased. If you were to look at it, for him the problem could be at various levels. Globally, you are looking that maybe it could be, let us say for instance, it is something like an aneurysm, which is a balloon, let us say a balloon which we see in the form of some bulge in some part of the body. It could be on the head, or it could be internal, or it could be something like abdominal aortic aneurysm where the abdominal aorta is bulged. So, if you would like to really analyze it, there are several scales which really take into account. There can be a very biomechanical reactions which go to the molecular level, and there could be continuum at a macro level things which need to be modeled. So, right from the continuum, micro, macro things need to be modeled. So, the scale at which the micro things work or even the atomic things work, that is different, and the scale at which the continuum things go ahead, that is at a different scale. you need to account for both the scales. So, you require a scale for atomic level, you require a scale for the micro level, you require a scale for the continuum level. So, that will go into the model. When you have such a model which has accounting the chemical reactions etc., which is at an atomic level or the molecular level, and the macro level things, the flow dynamics that you have, and at the micro level things which is going to be at a tissue level where these two things are getting interfaced. So, you need to have an appropriate models to capture all these phenomena to understand what is exactly happening, so that you will come up with a cure for it. But if you have a model, how do you handle this model with different scales? So, to handle these models in different scales, it is definitely not possible even if you have a mathematical model which is well posed both at the micro, macro and atomic molecular level. It may be well posed model, but they will be highly nonlinear coupled. So, you are completely out when it comes to getting a closed form, luxurious closed form solutions, because in this classes we learn about closed form solutions for very simple typical equations which are very easy to deal with. Such easy situations can model quite a few realistic things, but they are very limited. But the real life situations have got several complex phenomena which are governed by coupled nonlinear partial differential equations, and your models in terms of geometry is also highly nonlinear. They can be even moving. So, if you want to handle these things, you need to have an algorithm which will account for all the scales. So, that is where the multi-scale version of a numerical method need to be tailored. In this case, we are looking at multi-scale version, which means a methodology which is capable of handling all the scales, giving equal importance to a atomic, molecular, micro and macro level. So, each of these models should be equally given importance, and a model should be able to account for all these things and bring in the interaction between all these things to completely handle the problem in the right fashion. That is where a multi-scale method comes into the picture. So, the multi-scale version could be in any framework. For instance, finite element is one framework for handling the problems numerically. One could have a multi-scale strategy being adapted for any other framework like finite difference, spectral elements or finite volume. You could have a multi-scale method and all these things. But in this particular course, we will be focusing entirely on multi-scale finite element methodology. So, how to go about dealing different scales in the finite element framework. So, for that, and then we are going to focus, of course, we cannot handle all possible phenomena. We are going to focus on fluid flows. So, the multi-scale phenomena that exists in the fluid flow, for example, that is why I started with the example of cardiovascular dynamics. There is a multi-scale phenomena which occurs especially in a diseased or a pathological situation. So, to understand that kind of a phenomena where molecular, micro and macro things come into the picture, one need to appropriately tailor the methods or frame the methods in a way that all these scales are rightly represented and rightly handled. So, that is where the importance of multi-scale finite element methods in the context of computational fluid dynamics come into the picture. That I just started with the blood flow. There are several phenomena in the industry and engineering context where the multi-scale phenomena occurs. For example, if you were to look at weather prediction, there is also one can look at it as a multi-scale fashion depending upon the various your topic of interest. So, it could be the cloud bursting where the molecular interaction need to be taken into account with the airflow etc. So, you need to account for the cloud bursting, you need to have probably a molecular interaction, MD simulations probably need to be looked in. So, the various scales come into the picture there. So, or one may be interested in looking at a crack propagation in the context of solid mechanics. So, people look at near the crack they use a micro model or an atomic model, and then further for the propagation of it, one for the stress strain analysis of the entire structure one may use a continuum model. So, one need to have in a modeling itself there will be two micro atomic, micro and macro things come into the picture there. So, to capture all these phenomena in an appropriate way, you need to have a methodology which is capable of handling, and that is where the multi-scale comes into the picture there. So, as I mentioned, finite element method is one of the powerful methods which is capable of handling differential equations which are modeling the real life phenomena. There are several things in this because of its special features, especially to deal with the complex geometries, boundary conditions and non-linearities. Finite elements has got a great amount of success, and we will be focusing on this. So, the schedule of the lectures is as follows. Since we are starting, this is a workshop, we need to start with the introduction. So, we will today start with the very basic introduction, what are partial differential equations. I am not going to go into any of the details and the theorems and the proofs, but it is a recall. As it has been announced, it is going to be a quick recall on the various things. So, we start off on a very simple note which will help us to recall. So, we will first recall partial differential equations, and especially the second order and the higher order equations which are coming into the picture of modeling real life problems. Then we will move on to the basics, because we are going to deal with fluid mechanics, and then finite elements for fluid mechanics. So, we will look at to begin with the basic governing equations from the fluid mechanics point of view. We will review that in the afternoon. Then we will follow it up with computational methods for fluid mechanics, a general view. Then in particular we will focus it on finite elements. So, when we come to finite elements, we will have an overview of finite elements for fluid flows. Then we will look into what various aspects of finite element method. Before you apply what you are the important things that you need to take care, we will look into those things, and then we will first start with a simple mathematical note, starting with the elliptic differential equation and how the finite element methods are applied for that. We will look into that aspect, and we will cover all the aspects in this, and then subsequently move on to finite elements in fluid flows, which we will call as the first set of lectures for finite elements in fluids. So, here we will cover with very basic convection diffusion equation and get a feel for the whole thing, and probably we will also look at the Stokes equation by the finite elements in the Stokes, in the context of the Stokes equations, and we will look at well-posedness, we will look at the methodology, we will also try to look at the error estimates, convergence, we will also look at the results. All these aspects we will try to cover it. So, by then I would have set the stage for you, so that when Professor Kozina arrives on 7th of May, he will continue with he will start off from where I leave. So, he will take the crux of the whole course is the variational multiscale finite element method. He will start off directly on that. So, all the basics related to fluid mechanics, related to partial differential equations, and related to finite element method I will introduce, right. So, this being a course, I request you all to be interactive, feel free to ask questions, feel free to interrupt me. So, if you have anything to ask, then we do this. So, a course of this nature, which is of practical importance, will be insignificant if you do not follow it up with a tutorial or a lab session. So, I have already announced that all of you should bring your laptops. So, we will in the second technical session today, we will get introduced to what is called the FreeFEM FF++. This is one of the public domain softwares, it is open source, one will be able to download it. So, we will start right from how to download, how to install it, how to the basics of all the tutorial will start from 0. So, in the next 10 days we are starting from the 0, we will hope that we will first start with a very basic example like a Laplace equation, how to go about setting the whole thing and how to solve it. There are examples, we are going to go through the tutorials, and then we will interactively do the tutorials, copy the tutorials and run it, and then succeed in understanding. So, first we will go on a very slow pace so that we understand everything. So, we do the Laplace, we do some modifications on that, and then we move on to Stokes and Navier-Stokes. We will be able to do all these things. So, and then it depends on your ability. If you have your own problem of interest, then you will be able to attack it. And then when Professor Kozina comes, I think maybe once he introduces, he poses the problem, I guess you may be in a position to understand and try to slightly code it. As such, FreeFEM is a very user-friendly software, so with which you will be able to handle the things easily, but once we get used to it. So, I think 10 days is an adequate time. So, we do not have to worry, we are the beginners. I think there are a couple of students who are going to take lead. Halim and Meena will take lead in introducing these things to us. And I think of course, I will be always there. Then we can make it a very interactive session and then learn all the things. So, this is how the things go on. I think we will have lab sessions, the tutorials, wherever you have a problem, then a lab will be, it will be a lab or a tutorial. If you have something not clear in the lecture hour, we will discuss more elaborately in the tutorial session, right. So, its only thing is, so for whoever has come here, I expect that you are going to be very serious, you are a serious participant, that is why you are here, and I would like that to see in you for the next 10 days. I do not want any absentees in this. Okay. So, this has been specially designed, and I have given a 100% waiver for all of you, simply because I believe that you are interested and that you are volunteer to learn, you are interested to learn and take full advantage of it. Be very interactive and take full advantage of this course, and in fact, it is, I would say that the variational multiscale finite element method course is first of its kind in our country. As a course, maybe somebody has given a lecture elsewhere, but as a course we are doing it for the first time. I think it is a very one of the frontier topics. You will definitely understanding this in this course, probably you will get an understanding. Once you continue to work on it, maybe you will master it. So, the understanding and familiarity and removing the fear of what it is like is all the purpose of this course. And since you are a very limited number of people, about 10 of you, maybe 5 more will join us, and about 15 to 20 will be there. So, we have ample time to be very, very interactive and then understand the things, right. So, by the way of introduction, I am just done. I think I have just mentioned what is the expectation of this course, and as you know, if you were to look at the topics that will be covered in this, let me once again go over. So, introduction to PDEs, introduction to CFD, introduction to fluid mechanics and finite element method. I will take care of that. In the first 6 to 7 lectures, I will introduce all these things. So, by then Professor Kodina, who is the crux, who is the life of this course, he will arrive by that time. And then I think he will take over the next 10 days, he will be lecturing in great depth. And Professor Kodina is one of the stalwarts in the world who has great expertise in this area. He is one of the very well known persons in finite elements in fluids especially. He is one of the top persons in the world, and we are lucky that he has consented to come. So, I would very strongly suggest that do not miss any of these lectures, take very seriously, you will be able to really benefit a lot from this if you want to pursue a career in this. Of course, if you do not, if you just want to sit and see what it is like, I do not advise that you should do that. If you only go and serious to follow up this, it is meant for that. If you just say what it is like, I would like to attend it, then I think it is not meant for that. It is meant for the people who would like to really do this, just for time pass if you were to sit it, or just for what it is like. Well, I think it is not going to serve a big deal for you. If you want to really pursue a career in it, you can take a tremendous advantage from it. So, because Professor Kodina is one of the state of art persons in the world, and we are lucky that he has consented to come here, and when he comes, I think unless you interact with him, he will not know. You should be able to interact with him. So, do a follow up work when you are back home, so that I think when he comes, you have something to ask meaningful. You may have your doubts. So, of course, I will also be there. I think we will be able to help you out. So, just to review the topics that we are going to do. So, we are going to first as a review, it is a review only. I am not going to go into the details, because all of you are supposed to have some amount of expertise, because we are not starting at the basics. So, like a review on the PDs is going to be basically a review on the PDs. Today maybe I will start on a very simple note, and then we will review from different kinds of equations. We look at it linear, non-linear, various examples, everything we just recall, and then as we write the equations, we will also be able to talk about different areas. Then we will talk about recall. I am not going to derive the equations, straight away get into the equations meant for fluid flow. That in the afternoon I will do it. Then once that is done, then I will straight away get into the computational fluid dynamics aspect in a popular fashion. So, you get an idea of what it is, what is computational fluid dynamics, and what are the different tools which come, and what is it that we are going to focus. So, I will just give you a quick idea about it. Then we get into the technicalities of the finite element method immediately. It will be starting from tomorrow. We will go into technicalities of finite element method. I will start off with the elliptic equations and talk about all aspects, well posedness, error estimates, everything for the 1D case and the higher dimensions. Try to talk. Then we will move on to fluid flow equations, especially convection diffusion equation. Right. So, finite element method for the variational formulation for that, and the Galerkin finite element method. Then how you go about doing the error estimates for it, for the especially convection diffusion equation. We will discuss it in detail, and probably I will give some highlights on variational multiscale methods, simple highlights, so that we set up a stage for Professor Kodina to follow it up. When Professor Kodina comes, he will talk about multiscale strategy, variational multiscale framework, subgrid methods, the other related methods like symmetric stabilization, nonlinear stabilization, variational multiscale methods for Navier-Stokes equations, continuous problem, nonlinear splitting, subgrid scale, decomposition, so on and so forth, the numeric analysis of variational multiscale finite element method, especially the a priori estimates, convergence and stability. Then he will, after talking all the theory, they will also be talking about some examples from the industrial and engineering context: compressible flow, shallow water equations, thermal flow situations, Darcy problems, incompressible magnetohydrodynamic problems. So, in the lab sessions, we hope to cover Stokes and Navier-Stokes, starting with very simple Laplace, Poisson, and Stokes, Navier-Stokes. But of course, it will take time for us to get conversant with the whole thing, but I think we will attempt to do that. So, that is by the way of introduction. So, I hope that all of you will take the course seriously and interact, freely interact, very few of us, and then take the full benefit. I am sure you will really enjoy a lot if you were to really take the course seriously. So, be serious, attend all the sessions. So, do not take it light. If you have any intentions of just having a lighter view about the whole thing, I would advise you to become serious and do become benefit from it. So, take the full benefit from it. So, that is where I end, and with that I once again welcome you all to this course of MHRD. And we should, before I conclude, I should in this session I would like to thank MHRD GYAN program for generously funding the fund we got, especially for the external experts travel. His stay is honorarium is completely sponsored by MHRD. That is a very great boon. So, MHRD has envisaged such a thing to bring in experts from across the world to give us an opportunity to interact with them, and then this we are thankful to MHRD and the GYAN program for making such a facility available for the students, and that is why this is being video recorded, so that people across the country can also benefit from it, right. We are extremely thankful to MHRD and the GYAN program IIT being steered by IIT Kharagpur. We are thankful for them, so that I think so now we are also thankful to our institute for the infrastructure facilities and the multimedia facilities for recording this course, and also for the various support that we have got. Now, let us get into the technicalities. With that, I stop this introductory talk, and we will get into the first technical talk.